Okay, so now we're gonna start writing your peripheral driver. First things first, I have this GPIO files. I have a .h file and a .c file right here. Also seen obviously right here. What's gonna happen is I don't know if you made these new folders like I told you that I do, but you can go to add group and it'll make a new group for you right there, and then you can click on that group and you go to add new item to the group, and you're gonna add one C file and you're gonna call it whatever you want your driver to be called. I called mine HAL GPIO, which is hardware abstraction layer GPIO. So you're gonna add one C file, call it whatever, and then you can go again, right click, add new item to group, and you're gonna add a .h file. Typically I call them the exact same thing, so I know that they're both, because they go hand in hand, so that's why I call them the same thing. So yeah, so you're gonna add these two files, call them whatever. Once you do that, you see yours is gonna look different. It's not gonna have this little thing here because I already typed something into the C file, so that's why it has that. But for the most part, yours is just gonna be a blank file like that. Okay, so let's start I guess filling in the header file. First things first, you're gonna do this if not defined HAL GPIO, and this doesn't have an H on it, and this is just the name of the header file that goes here. So the exact name you typed in for the header file minus the extension. Don't put .h. So just HAL. This is what I called mine, HAL GPIO. So HAL GPIO. That's what it is right there. Okay. The next thing you want to do. Well, this entire thing gets your entire header file is gonna be right here in the middle, in between all of these two things. So you can go ahead and make a lot of space there. The next thing you're gonna do is you're gonna include the header file for the microcontroller that you're using, which can be found right here under devices, and you expand this and you'll see it right here or anywhere on this list, the Stm32F10x.h. So you can include that file. And me personally, I define all my GPIO ports. Instead of saying GPIO, I just define them as ports: port A, port B, port C. So that's what I've done right here. So I've taken all my GPIO definitions and I've just redefined them as port A, port B, and etc., etc. And I don't even have this many ports on my microcontroller, but again, if I ever want to use another one in the series of these microcontrollers that do have these, I'll be good to go. Now I'm going to make a definition for two specific output or input modes that I'm going to have. So either I'm going to be in output mode or input mode, and I've just assigned a value to them here. I typecasted this into a 32 unsigned integer. Now the value that I put here doesn't mean anything. It's just any value, and they just have to be different because I'm just going to use these variables right here. Or these I'm just gonna use these macros in an if statement. So as long as they're different, that's all that matters. I just chose 1 and 2, but that's all that's for, just so I can pick my my pin modes. Now the next thing I'm gonna do is I'm gonna go and I'm gonna make some defines for the input modes. Well, ultimately we're gonna make a define for all of these. So we're gonna start here. So I have 3 input modes: analog mode, which is equal to 0, 0. Floating input, which is 1, and input with pull up, pull down, which is 2. So I'm going to make define modes that correlates this with this data that we have here in the data sheet. So that's that right there. Input analog, floating 0, 0, 0, 1, yada yada. So all those things right there go with what's on the data sheet. And again, the reason I'm making this is so that when I'm shifting code and shifting bits, I'm not gonna be shifting 1s and 0s and stuff. When I write a certain value into the register, instead of writing 2, which I'll look at my code, I'm like, okay, I wrote 2 there, but what the hell is 2? What does that mean? So instead of 2, I'll write this, input pull up, which is a lot more readable. I'm like, oh, okay, I set it to input pull up, you know. So that's the whole purpose of this. Now I'm gonna go ahead and I'm gonna make some definitions for some defines for the output modes, which are these 4. So let's go ahead into the let's type that. So that's that. So I have those different output modes, and I start each of them with either input or output, so that when I'm typing and I forgot exactly what it is that I wrote, I can just remember that I typed in output in the beginning. So I'll start typing that, and then you'll get the little pop-up window, and then these options will pop up, and you can, okay, yeah, this is the one that I want, you know. Okay, so what's next? So I've taken care of that, and now we're gonna type in well, basically this right here, just these speed modes. Okay, and I don't have to type in this one because I already have an option for input mode, which I wrote up here, input mode or output mode. So I'll just check if it's this, and I know I have to type in 00. So I'm gonna just do the defines for this one, for the different output speeds or slew rate, whatever you want to call it, if you want to be technical. So here we go. So we have the speed for 2 megahertz. It's equal to 0x2, 1, and 3. Okay, so that's that. Now you also have to remember that anytime you're using a port, you have to enable the clock, because by according to the data sheet, when you reset the microcontroller, all these clocks are actually off. So I went in and I made some definitions that that enable the clock, which is this is what this does. If you remember from my introductory video or one of the other videos where I showed you how to enable the clock, well, by looking at this, I don't know what for or which clock I'm enabling, but this right here is a lot more readable. And GPIO clock enable port C, for example, you know what I mean. And I uncommented this one because I don't have a port for that, but whatever. And this is to enable the alternate function, which we will use in once we get into the handling the interrupt for the pins, which will be in a later video. But for now, you just set these ports because these are the ones that are available in the microcontroller that we have. Now I need a way that if you remember, pin 0 starts here. Remember, we have a control low and a control high register. Well, I want to find a way to find a position for all my pins. Okay, so if I want to get to the, let's say, to the mode position right here, right, for the, let's say, for pin 12, I don't know off the top of my head which bit starts pin 12, and if I look here, pin 12 starts at bit 16. Okay, so off of my head, I didn't know that. What about pin 13? Oh, it starts at pin 20. There's no logical way I can think of, okay, pin 12 plus 4 is 16. Okay, maybe that's a pattern, but 13 plus 4 is not 20. So there's no real pattern that, at least that I can see, that's obvious, that I could say, okay, there's a pattern. There isn't. So what I did is, in order for me to find the first bit for my pins, and when I say the first bit, I'm talking about, you see how this is configuration 10 and mode 10. So the first bit that starts all the settings for pin 10 is 8. So that's what I'm saying. I need to find a way that I can find the first bit where each pin starts. So if I want to go to pin let's say 6, I need to find a way that I can say go to the position for pin 6. In other words, go to 24 right here, because this is where pin 6 starts. So my idea, again, if you can think of a better way to do this, by all means, please. But if not, what I did was I just made an array. It's called pin position, and it has 16 elements, which is 0 through 15, just like our port. And index 0 in my head is going to be equivalent to pin 0. So I